send out automatic position reports by satellite.
The reason for the automatic position reports is so that the operator can follow the progress of the flight and know whether it's going to be early or late to help with its scheduling effectively.
Cable uses the automatic reports to track the flight's further progress. The last location was at 2:10 a.m., 70 miles from where the wreckage was discovered.
What these messages do show is a last automatic position report and then apparently the end of the flight.
Something in Flight 447's path brought it down. Cable hunts for the cause in the official weather report.
There was thunderstorm activity in that area, quite a large trail across the flight path at the time that AF447 went through.
At 2:10 a.m., Flight 447 was in the vicinity of an Atlantic thunderstorm, 250 miles wide. But this fact raises a crucial question that the official reports fail to answer. Why would experienced pilots fly into a storm?
The idea that a pilot would fly through a thunderstorm, absolutely not.
Highly improbable. Pilots, remember, at the front end of the airplane, the first people to meet any accident. We have a great incentive not to meet accidents.
Flight 447 must have flown into the storm by mistake. To find out why this happened, the investigation turns to John Williams, a specialist in aviation meteorology at the National Center for Atmospheric Research in Boulder, Colorado. Williams has satellite images taken every half hour to analyze how the storm developed as Flight 447 approached.
I'll step through by 30-minute intervals, and you'll see these storm systems starting to grow. This storm system is hundreds of miles across and maybe 60 miles wide. Wow, look at the size of that growth right there.
In daylight, the thunderclouds would have spanned the horizon, towering from the ocean to 50,000 feet. But in the dark early hours of the morning, the Flight 447 pilots can't see them. Instead, they must rely on their onboard weather radar. Radar waves reflect from water droplets in the clouds, allowing pilots to pick their way around any dangerous storms. According to the official reports, several other flights that night took the same route as Flight 447. But all these pilots saw the storm coming and made detours of up to 90 miles to avoid it. But Flight 447 made only a minor change of course.
You can see that it had deviated a little bit off of its flight plan, and that might mean that they were trying to deviate around some storms.
This minor deviation leads Williams to a major breakthrough. He thinks Flight 447 was deceived by a quirk of the weather.
What you can see is that there's a small storm between them and the large storm system that, as they approached it, may have blocked their radar's view of the larger storm system and the more hazardous storm system behind.
If Williams is right, Flight 447's radar was blocked by the smaller storm in their path. The beam can't get through to detect the real threat, the 250-mile-wide storm system behind. Supporting Williams' theory, another flight crew that night reported that they only saw the danger when they increased radar sensitivity.
You could find yourself in a position with this absorption of the signal where you are almost into the storm before the signal strength actually reflects the reality.
It's an important step in the investigation, filling a critical gap in the official reports. It's possible that by the time Flight 447 saw the danger on radar, it was already too late to turn around.
You have no option but to take the least worst exit.
The crew must ride out the storm. They face two potential threats. The first, lightning. Aircraft are struck once a year on average. But modern airliners are protected against even the most severe lightning. This Boeing 747 incident was captured on a mobile phone. Spectacular, but the lightning passes harmlessly through the outer skin. The 747 landed safely, with no significant damage. No modern airliner has been lost to lightning since 1963.
The thought that lightning could be a serious effect in the accident of Air France 447 is extraordinarily remote, and there's absolutely no evidence of it.
The second threat, turbulence, is more serious. It's caused by updrafts, rising pockets of air punching up through the storm towards Flight 447's altitude. The white areas on John Williams' map.
There's one here and one here, just off the flight track of Air France 447. Hitting an updraft would be like a jackhammer hitting you from below. It could really give the aircraft a jolt.
As Flight 447 headed for turbulence, the automatic systems would have kept everything under control. The pilot's next move is standard procedure. Anticipating turbulence, he asks the passengers to fasten seatbelts. Then, as a safety measure, he dials in a slightly lower speed to reduce the stresses on the aircraft. An automatic system called auto thrust takes over.
The autothrust would reduce the power on the engines to slow down towards your target speed.
Everything happens automatically, so the pilot's manual thrust levers don't move. As turbulence hits, sudden updrafts throw the aircraft up and down. But auto thrust changes the engine power to compensate, maintaining the aircraft in a safe speed range. All the pilots have to do is monitor the instruments.
The systems automatically will tell you if they get out of limits, but you could be looking at the systems from time to time just to check that they are well inside limits.
The investigation has traced Flight 447's progress to its last known position. They're in the midst of a rapidly developing storm that their radar detected too late. The pilots have no option but to ride out the turbulence. But their automatic systems provide reassuring protection. It's 2:10 a.m. The evidence suggests that little more than 4 minutes later, everyone on board Flight 447 was dead. Automation gives the investigators a crucial window on what happened next. Just after 2:10 a.m., the flight computer suddenly sent a torrent of fault messages to Air France in Paris. These so-called ACARS messages now form the central focus of the investigation.
It really is the last will and testament of the aircraft.
Flight 447 suffered 24 critical faults in just 4 minutes and 16 seconds.
You can just see an aircraft almost dying in front of you.
The tantalizing cryptic messages are the only evidence that can cast light on Flight 447's final moments.
As the last message from the aircraft, they may well tell a very great deal about what happened.
Tony Cable decodes the data to reconstruct events on a second-by-second basis.
The first ACARS message that appears is autopilot off, and that indicates that the autopilot has disengaged on its own. There is a master audio warning, which is a real attention getter.
The pilot must retake manual control. But now another critical message. Auto thrust off.
It means that the system that normally automatically controls engine thrust to maintain airspeed and altitude is no longer working.
The alarms keep coming. The most critical safety features are failing, one by one.
It must have been a very busy and confusing situation on the flight deck.
The automatic systems are shutting down. Then, one final ominous message.
The advisory cabin vertical speed message means that the pressurized cabin is descending at a high rate. In other words, the aircraft is descending at a high rate.
The last message came just moments before Flight 447 and its passengers hit the water. But what could have caused all the vital automatic systems to suddenly malfunction?
The reason for the autopilot kicking out is something that clearly needs to be established.
Tony Cable scans the ACARS messages in search of the root cause. And he thinks the multiplying faults can be traced to just one.
Pitot probe messages are particularly significant. It's a very basic parameter for the aircraft.
If Cable is right, this single cryptic message means the automatic systems can no longer function, because the flight computer doesn't know its most vital parameter, its airspeed. All airliners measure airspeed using pitot probes, forward-facing hollow tubes of metal just below the cockpit. In case of failure, there are 3 probes of identical design. A supposedly fail-safe system because the automatic systems can't operate without them. But on Flight 447, the crucial pitot probe message says something went wrong.
We know that the airspeed indication systems, all 3 of them, were compromised.
Tony Cable plans to find out why this most critical of aircraft sensors failed in the wind tunnel.
Okay, Cliff, can you take it up to 30 knots for a try this time?
A pitot tube measures the pressure of the air rushing into its open end. The computer converts this pressure into a wind speed. In this case, around 30 knots. But Cable can make the pitot tube malfunction by just blocking the end. The measured airspeed drops to almost nothing.
1 to 0, yeah.
At high altitude, the most likely way a pitot tube could get